Okay. Future of Transportation, Electricity and Magnetism by me, Jordan Kyle Farnsley, for Physics 2020. All right, quick outline. Introduction to transportation. All right. Fossil fuels, magnetism, electricity, and the future of transportation. All right, a quick abstract. This essay discusses the future of transportation in fields of electricity and magnetism. It contains a brief history of transportation and why we must expand our sources of energy to fuel future generations of transport. A discussion of the utmost realistic and efficient modes of transportation will explain why they are the most relevant choices today. All right. First, modes of transportation. Hope you can see all that. So basically, since the beginning of time, humans have been looking for more efficient ways to move themselves and their belongings. First, we had boats, very, cavemanish things, boats, and then, we used horses, and then some guy invented the wheel somewhere along the way, and that's all great. Everybody knows that. But in 1796, the invention of the Watt steam-powered engine was used on boats first, and that was a big step. And then also in 1801, the first mainstream locomotive. So everybody knows choo-choos are the way to go. It wasn't until 1858 that the internal combustion engine was first established. But we actually give that credit to Carl Benz in 1886 because he filed it with a patent. Way to go, Carl. But by the start of the 20th century was really when things got going with the two brothers Orville and Wilbur Wright. They did the first flight in 1903. And that was a big deal because, as a society, we try to we want to conquer land and sea, and then after that, we're going to the sky, and then before you know it, we're doing the space race, and that was between the Soviet and the United States, and we won, go America, but yeah, so that's a quick history on the first mode of transportation. All right, fossil fuels. So, this is what we really ran all of our our past transportation off of. But as you can see, it is depleting. It is going away. It's non-renewable, and a lot of people think they're going to be gone, by 2088. But this passage actually suggests maybe not quite that quickly. But in 2088 marked the point that we'll run out of fossil fuels. The simplest answer is no, but some new reserves have been found, which will slightly extend the deadline. But basically, they can't last forever. Right here, you can see this is coal, okay, and this is 2088. So that's going to last for a little while. But then we've got gas right here, natural gas. This is not looking good. We're out in 2051 or 2061, and then in 2051, that's when our oil is going. But we're finding new reserves of fossil fuel, but they're significantly smaller. Okay, so this is not a good thing, and we need to think to the future. As I said, they're non-renewable. Environmental concerns, as you can see, global CO2 emissions from the coal, they're going way up. We're increased. This is an older picture, but 50% from 1990 to 2009, and it's killing Mother Earth. It's killing everybody. So it's good that we move forward. The future is now, and we have to create new resources of energy for many reasons, but most importantly, transportation, because everybody's got to get around. Most of our main modes of transportation run off fossil fuels, but like we said, they're not going to last. We've relied way too much on them, and this is exactly why we have to push the creation of more electric and magnetic forms of energy. And that's exactly what we're about to talk about. All right. The first field of transportation that we will discuss is magnetism. So, there are no magnetic powered cars or boats or planes, but there are magnetic powered trains. And these trains are called maglevs, and they are actively being used in Germany, China, and Japan. That sounds pretty cool to me. The term maglev is derived from magnetic levitation. It's a transport method that utilizes magnetic levitation to traffic vehicles without making any connection with the ground. Okay, so no friction, which is really cool. The vehicle is taken along a track using magnets to create propulsion and lift. In doing so, reducing friction by a tremendous amount and providing high speeds. So, I mean, it's much faster than, planes even. I think I read somewhere where they go 500 miles an hour. It's pretty fast. Compared to normal trains, maintenance is very minimal because of the lack of friction. The friction and wear on normal trains prevents the high speeds and causes more issues. The frictionless ride of the maglev provides it's an extremely smooth ride for the passenger, and the ride is not affected by bad weather, supposedly. That's what I read. They're said to be up to 30% quieter and all around more efficient train. So, it's coming. It is the train of the future. But the only thing is, on the other hand, these maglevs, they're more expensive to build, of course. But, the initial investment, if it's a long-term thing, then, we're all about it. But you also have to construct a track in, these major cities where we already have, lots of traffic. So, but that is a quick overview on the maglev. And this is a little bit more about how it actually operates. So the coils run along the track and repel the large magnets on the train's undercarriage, allowing it to levitate. So it's in the air, and once the power is supplied within the walls to create the unique system of magnetic fields that push and pull it along what they call the guideway. All right? So it's basically the track. The electric current supplied to the coils is constantly alternating to change the polarity of the magnetized coils. This change in polarity causes the magnetic field in front of the train to pull the vehicle forward, while the magnetic field behind the train aids more forward thrust. So, I don't know. I might have to go to Germany and check it out. We'll just have to see. Maybe they'll put one in Knoxville or something. Alright. So, the next field that we are going to look at is electricity. Electricity is stored in many different ways, including solar, wind, and hydraulic. Everybody knows this. You've got your windmills, you got your solar panels, you got your dams. This is how we get the energy, and what we do with the energy is we can actually store them in batteries. Okay, and with those batteries, we can power cars. So this is our second mode of transportation, the electric car, along with the maglev. And I want an electric car. I think they're pretty cool things. But basically, the electric car, it's not a new concept. It's really become relevant with numerous groups of people who are all concerned with the future of energy and the world as a whole. And that is myself. Electric cars get their power from